Welcome back, guys. Today we are back with another problem, and today's problem is working on the alien dictionary. Okay, so this is an important problem, as important the name sounds. So the problem is an alien dictionary. Okay, so as we know that human beings speak with in the English language, and the English language has some alphabetical characters which are arranged in a sequential manner. So the characters which are arranged in sequential manners include from A. So the characters which we speak include from A to Z. Okay, and it follows a certain set of rules. So A comes before B, then B comes before C, D, E, F. Similarly, it follows all patterns. Okay, so this is following a particular pattern where A is coming before B and B is coming before C. Okay, so this is our language. But over here in this question, it is saying that the aliens are not following this particular pattern, whereas the aliens are following some different pattern. So how we are supposed to know, and we have to, it is saying that we have to, according to the question, we have to find the order of the characters in the alien language. Okay, find the order of the characters in the alien language. Okay, so here the order of the characters B, D, A, and C. Note that the words are sorted in the given. B comes before B is before A in the output. Okay, so let us understand this particular problem, and let us analyze this particular problem and how we are going to suppose to solve this particular problem. Okay, it's saying we have to find the order of the characters in the alien language. Many orders may be possible for a particular case. You may return a valid order and output will be 1. So whenever we are returning a valid order, only then the output will be 1. If the order of the return function is correct, if the order of the string returned by the function is correct, else 0. So if the order is not valid, we are going to return a 0, denoting incorrect string returned. Okay. So let us understand this problem and how it is saying. So this was English. Okay. So this is known as English, as we all know. But now let us compare. Now let us draw a comparison how the alien is communicating with their languages. Okay, so when the alien is speaking, it is saying that it has some set of words in a dictionary. Okay, so the words will be like, say, B double A as given in the question. Okay, and then the alien is saying we will have A, B, C, and D, A, B, C, and D. After that, A, B, C, and A, B, C, and A, and then we have, then the alien is speaking C, A, and B, C, A, B. Okay, and the alien is speaking C, A, and D. Okay, so if I carefully observe that how we are going to solve this particular problem and how we are going to understand. So if I want to generate a valid order which the alien is saying according to this particular set of words, say I count the words in the dictionary from 0. Okay, so here my words start from this. Okay, my words are 0, then 1, then 2, then 3, and 4. Okay, the question is also saying that and a k starting alphabets of the standard dictionary. So if we have k equals to 4, that means we can assume that the standard dictionary, the first 4 letters A, B, C, and D, but we don't know in which order it is. It can be C, A, and B, it can be B, C, A, D, it can be any X, Y, Z order. Okay, so they have not specified that what type of order it is, but we can assume any given order. Okay, and K basically denotes that. Okay, so now let us come to how we are going to understand this. So if I am checking, say I will be checking in pairs. Okay, I will be checking in pairs. Okay, and then we can understand how it is working. So let us take the first 2 words of the particular alien dictionary as B, A, and then A, B, C, D. Okay, so if I check now, B is coming before A. So here I can draw one conclusion that the alien speaks like this, that in their language the B is lesser than A. Okay, so according to the alien language, the B is coming before A. Okay, so what next? Let us come with the second pair. Okay, so according to the second pair, we have A, B, C, and D, and the third pair I can check is A, B, C, and A. A, B, C, and A. So now if I check, okay, these values are equal, these values are equal, these values are equal. But what I can see is D is coming before A. So another rule I can draw from here, that in the alien language, the D comes before A. The D comes before A. Okay, so what about the other 2 pairs? What are the other pairs do I have? So according to me, the other pairs I have is A, B, C, and A, and C, A, B. So A, B, C, and A, and second last is C and A, C, A, B. Okay, so now if I check the pairs, what I can see is A is coming before C. So here I can draw another conclusion that A comes before C. Now let us check the last 2 pairs, which is C, A, and B, and C, A, and D. So C, A, and B, and C, A, and D. So what I can draw from here, another conclusion, that B comes before D. So what type of sequence it is following? So if I was to draw a particular order out of all these orders, my given order would look like, say it is saying B comes before A. So first let me write the characters. B comes before A. Okay, so I can write B comes before A. Now we have D comes before A. That means D is also coming before A. Okay, it's kind of like a mind game. Okay, now what you can see is A comes before C. That means the C obviously has to be somewhere over here, and then B comes before D, which satisfies this particular condition. So this is the order which I will be getting. This is the order which I will be getting, and this order can be achieved with the help of a topological sort. So we can achieve this particular order of the aliens with the help of a topological uh, topological sort. So topological sort basically works with the help of three things. So how we will be doing this, I will be telling you. So first you can see that the letters which I have. Okay, so the letters which I have is B, A, and then I have A, B, C, and D. Okay, and then I have A, B, C, and A, and lastly C, A, B, and the last is C, A, and D. So the topological order is, the first is I'll be taking the words in the form of a dictionary, right? So I can say this is my first 0, 2, 3, and 4. As my value is k equals to 4. Okay, I can take only these possibilities of the things. Next, what I will be doing is, see, I have already got these values. Now I have to make some sort of a graph reference of these values, some sort of a graph reference of these values. So let us understand what are the conclusions I draw. So it is saying that B is lesser than A. Okay, so I can make a node B, okay, which is pointing to the edge A, as B is lesser than A. Okay. Next we come is D is lesser than A. So there can be another node D which is pointing to this particular A. Okay, that also I can get. Now what I am getting is a node A is lesser than C. So that means this A is pointing to some value which is C over here, okay, and lastly B is pointing to D. So B is pointing to D. So what I can see now, what type of graph do I have? What type of a graph do I have? What can I call this particular graph? So this is called directed acyclic. Okay, directed acyclic graph. Okay, I can call this as a directed acyclic graph. So now what my algorithm will basically be like. So I have, say for example, I have to check the words word wise. Okay, so now if I have, say, two words B, A, and the second word of the pair is A, B, C, and D, I have to check this particular character present in this first word, which is I equals to 0, with I plus 1th word, okay, which is particular this, and so the sequence goes on. So what I will be checking is, so my first string, say S1, will be, say, the character array or the word array. So word array of I, and my string S2 will be the array of I plus 1. Okay, now I have to check the equality condition, whether this is equal, then it's okay. If it is not equal, then I have to sort it according to a given order. Okay, so this is to be done with the help of the topological sorting algorithm. Okay, so let us go with the coding and implementation part, so we can understand this problem in a more better way. Having a list of type integer, okay, and we can say this as graph where we are going to store. Okay, so we can say new array list of we can say the new array list of size k, right? So new array list of size k. So we can just write k. Okay, so once I have this particular thing, what I can do is I can traverse to the list. Okay, for int equals to 0, I less than k plus plus. Okay, now I can have graph of the ith value is equals to new array list. Okay, new array list. So for loop is being completed. After that, we can use an array to store the in degree. Okay, so what is basically the in degree? So the degree means the number of connected components with a particular number of connected components with, say for example, if I check this particular thing, so if you see B has a degree of 2 because it is connected with 2 values. Okay, so similarly, what I can do is over here, I can write, and in the in degree, what I can write is I can int I can check in degree, okay, equals to new int of k, size k. Okay, then I'll be having a loop I equals to 0, less than n minus 1, plus plus. So why we are taking n minus 1? As n minus 1 we are taking because we have to check our consecutive elements. So that the array does not becomes out of bounds and it moves to the next, and then it doesn't find any more elements left in the end. That's the reason we will be using I is lesser than n minus 1. Okay, now we can have a string word. Equal to dictionary of I. Okay, and we can also have a second word, the word which we will be checking. So we can have a second word and we can name it as I plus 1 and make this as dictionary of word 2. Okay. Now after I'm done with this, I'm going to take sorry, I will be taking the length. So I can say int length equals to uh, math. I have to take the minimum length. So minimat dot min, mat dot min. I can say word one dot length, word two dot length. Okay. So I've taken the two words and their lengths. Okay. Now I'll be using another nested loop, say j loop. J will be from 0, j less than n, j plus plus. Okay. So once I have this, what I'll be checking is I'll be checking the initial characters of the two words. So I can write it like this, that word one dot char at of j, okay, is not equals to word two dot char at of word two dot char at of j. Okay. So if they are not equals, I can make the edges and the nodes like u equals to word one dot char at of I, sorry, j. Okay. Minus of a. So what does this does is converts string value to integer. Okay. So I've done this for word one. I've done this for word one. So I can do for v equals to word two dot caret of j minus of a. So which gives me the same thing. It can convert it. It can convert over here. I can write the same thing. Converts the string value into this particular thing. Okay. So once this is done, I have to add in my graph. This is the graph I made. Okay. Add a list of graphs. So I can write graph. Okay. Graph u dot add v. Okay. Now in degree of v plus plus. Okay. Then break. So yeah. After that, what I'll be doing is I'll be performing the breadth first search algorithm for the topological search. So what I'll be doing is I have to if I j. Okay. So what next I can do is I can perform topological sort using Kahn's algo. Okay. So what I'll be doing first is I'll be taking a queue data structure. So I'll be storing a queue of type integer. Say we can write q equals to new linked list. Okay. After that, I'll be having a string builder object. Say ob equals to new string builder. Okay. Now what we will be doing is now we're adding the nodes, particular nodes with the in degree to 0. So I can write add nodes with in degree 0 to the queue. Okay. So for that, the loop I'll be using is for in I equals to 0, I lesser than k, I plus plus. Okay. And I'll be checking whether my in degree is 0. So in degree i of I is equals to 0. If this condition is satisfied, what I will be doing is q dot add. I'll be adding an I. After my for loop is completed, I'll be traversing through the queue till it becomes empty. So I can write q over here. I can just write q dot add. So I'll write q dot is empty. Once it is checked, I will be adding the elements to the queue. Q uh, q dot pull. Okay, and order will be completed order. We have to return the complete order. So if it is valid, then we will be returning a 1. Otherwise, we'll be returning so u plus a. So what does this? It basically converts it back into character. Okay. After that, we can have for loop over here. So in the for loop, we can say in v belong to the graph. Okay, of u. We can have an in degree. We can have in degree of v minus minus. Okay, if if my in degree of v is equals to 0, then what I will be doing is q dot add v. Okay. After that, I'll be checking if the order contains all the characters. It's a valid topological order. That's a quite long code because it's a hard problem and usually IOI based problem. So order dot length equals to a. We can return order back to string, order to string. Okay. Else, what we can do is we can return a blank value. So we can just compile our code So cannot find symbol order dot append. So let us symbol order dot append order. So we have taken it as OB, right? So we can write OB as our string builder object. So everywhere we have to check the word OB instead of the order. Now let's compile. So you see that we are successfully running our code. And this was the problem about the alien dictionary. And I hope you enjoyed the explanation. And we are looking forward to solve more problems, more hard problems on strings and graphs and array lists and so on. So thank you so much, and make sure to like, share, and subscribe to the channel.